now going to look at analog inputs. Analog input is very different to digital inputs that we use with the button. We'll start off by loading up the sketch called Analog Input, or 05 Analog Input, from the sample sketch, and I've got it up here on the screen now. We'll start off by just loading that up to the Arduino so we can demonstrate what's happening, then we'll come back to actually look at how it works. At the moment, that's loaded the sketch and it's running, and we're taking a value from the potentiometer, or the variable resistor, and it will vary depending on where we turn it to. So as I turn it to the left, it's flashing faster, and when I turn it to the right, it starts to flash slower. Let's have a look at the sketch and see why that's happening. In the beginning here, in the declarations, and I'll just separate that a bit to make it a bit clearer, we've set our sensor pin, that's where the potentiometer is connected, as A5. So that's analog pin 5. And if you have a look at the Arduino board, you'll see that says pot A5, so that matches the thinker shield. LED pin is on pin 12 again, so we're using the LED 12, and the sensor value is where we're going to store the value that we get from the potentiometer, and at the moment we just set that to an arbitrary value of 0, just so that we have a place to store it. In our setup, we've got pin mode, LED pin is an output, sensor pin is an input, because we're receiving information from the potentiometer or value. The serial begin, I'll come back to that a bit later. When we get into the loop, the first thing we do is we read the value from the sensor. So in our last sketch, we used digital read. Here we're using analog read. So we're telling the Arduino to look towards the analog port, pin 5, because sensor pin is 5, and get a value. And it stores that value at sensor value. So sensor value will equal what it reads from the sensor pin, or pin 5. We're now turning the LED on, digital write, LED pin high. Same command as we used in Blink and the other sketch as well. Then we're putting a delay, but instead of putting a value or a fixed value into the delay, like we did earlier where it was 1,000 for a second, we've put the word sensor value. So it's going to take the value that it read from the potentiometer and put it in, and that's how long it will delay. Then we'll go back to digital write and turn the LED off, and then another delay of the same amount as we delayed before. So when this is turned to the right, we're getting a high value, and it's blinking at about 1 every second. And as we move it left, we're getting a lower value, and it blinks at a higher rate. So the lower value reduces the delay between the flashes.
This animation will explain the difference between analog and digital signals. This is a bilge pump switch from a boat. It turns a pump on when water gets into a boat, so it can pump the water out and stop the boat from sinking. The float on the switch rises and turns on the pump. When the float drops down, the pump turns off. This is a digital switch. It is either on or off. There is no in between. On is like a 1 or high in the code. Off is like a 0 or low in the code. Now let's look at the analog sensor. As the car drives along, the fuel level drops and the gauge drops too. The value sent from the fuel level sensor is slowly dropping. If the car drives faster, the fuel drops faster. As the car fills up, the value from the sensor goes back up. And as it drives, the sensor value drops. On an Arduino, the value of an analog input varies between 0 and 1023. The potentiometer is also an analog device and works in the same way. As the potentiometer turns, the value read by the Arduino starts to rise. The highest it can go is 1023. All analog sensors will return a value to the Arduino between 0 and 1023.
So the digital can only be 0 or 100%, whereas the analog could be something in between. To get an idea on what that value is on the screen, we can go into a serial monitor. And that's up here on the right-hand side of your program. If we open that up, I'll just make it a little bit smaller, you can see it saying the sensor value is 450. And if I turn it to the right, it'll increase. And if I turn it all the way to the right, it should give us a value of 1023. So that's 100% of the value that it can give. And if I turn it all the way to the left, it will give us a value of 0. If I turn it halfway up in the middle somewhere, as you can see, it starts to rise and starts heading up towards that 1023 again, depending on where the potentiometer is. Now, this is called the serial monitor, and it's set up by that line that I went to before, the serial begin. Let's move that across. Serial begin is in the setup section of the code, and in here it's set at 9600. So serial begin 9600. If you get some other code from somewhere else and you run it on your computer, you might find that the value in the serial monitor is different, and you have to make it match the value down here in the bottom right. So for example, if I change it to this value, which is a lot higher than 9600, you just get symbols and things that don't mean anything. So the number here, that's called the baud rate. It's the rate that the communication is happening between the Arduino and the computer through the USB cable. It has to match what you've written into your code. Down the bottom here, so that's in the setup, and down the bottom here, it says serial print. And just to make it easier, we've written in inverted commas, so it just writes the text, the sensor value is, and on the next line we've said serial print ln, which is line, the sensor value. So whatever value it's reading from the potentiometer at the start, it prints that on the screen down here. The ln, so this one's serial.print and this one's serial.print ln. The ln just means it goes to a new line after it's printed. So you can see, as we turn that, we can get the different values, and that can be really handy when you're setting up your code to do something that you want it to do and you need to know what value it's reading. A good exercise here is to change this to A4. A4 is the light-dependent resistor that's on the board, that's over here. The light-dependent resistor varies its value based on how much light is falling on it. So if I cover that up, you'll see you'll get a very low value, and if I uncover it, you're starting to get values in the 300s, which means that the light-dependent resistor, which is here, it's picking up the value from that. And if I cover that light-dependent resistor, it gives a lower value, and as you can see on the screen, it's now giving you values in the 60s, and when I take my finger off, it's increasing its values up into the 380, 390, around that mark. And that will vary depending on the light. So if I half cover it, it'll give me a value somewhere in between. And if I totally cover it up, I can get it right down close to 0. This can be really handy if you need something to turn off at a certain level. For example, a simple example is a night light. So as it gets dark, you want the light to turn on. So you would set an if command that if the value is less than a certain number that you've preset, it'll do something like turn a light on. But to work out where that value is, where that threshold that you want to turn it on and off, that's why we use the serial monitor, so we can get a reading of what it is in the light, what it is in the dark, so you can pick your threshold at an appropriate level.